Hello. Today we are going to be practicalizing our previous discussion on one sample to test using SPSS. Before we go through the process, I would like to really discuss what we discussed in the last video. We said one sample to test is a test used to test the mean of one variable. That is basically the meaning of that one sample to test. One variable test. We are testing a variable using its mean, its calculated mean, for using its calculated mean to test if the mean is significantly different. If the mean is significantly different. And how do we test it? We test it with some other means, which can either be a midpoint, which can as well be average value from past research, and also performance level. But I said we are going to be limiting our discussion to two, which is actually the midpoint of a value of a variable and also the average value as well. So in this sense, what one sample to test will do is that it will test this new midpoint, this new mean that we are going to be getting, which we are going to be practicalizing any moment from now. It will test it with other mean, which can either be the midpoint or mid value, and also the average value. So if it is an average, if it is a midpoint, what we are saying there is that an already predetermined midpoint, an already predetermined value has been made. Now we want to justify that mid value if it's significantly different from this new mid value, this new mean that one sample to test will calculate for us, that SPSS will calculate for us. So that is basically what we want to do. A previous midpoint and this new mean or midpoint, testing it if they are the same. If it's an average value based on past research, what we are saying here is that a previous research has been conducted earlier, maybe somewhere, or maybe 5 years ago in a particular area. So we now want to test if the previous average value, the previous mean, is significantly different or is still the same as this new mean we are getting now. Say for instance, we want to know the average age of people going to the university, average age of students going to the university, and you take your time to sample out maybe 100 people, 100 students in the university, and we calculated their age. You got to realize that the average age was 25, maybe in a particular area, let's say in Osun State or in Lagos State. I'm now coming to Akure here. I want to know the average age of people, of students going to the university, and you want to relate your previous research, your previous findings, which was actually 25. You want to relate it to Akure. You want to relate it with Akure. So in that sense, what you're doing is you are trying to significantly know if there is a difference between the midpoints, between the average value, sorry. So in that sense, you tell SPSS the previous average value and tell it to calculate to see if there is a difference between them. So that is what one sample t test will do for you. So now we are going to practicalize it. Now, to do that, I've actually entered the data, which I think what we just need to do now is to delete this new wait time and also end wait time, so we can do this one, and so we see how to go about it. Initially, this is actually the data set wait time. what this data set is talking about is that we want to know the waiting time with which a patient had to wait in a hospital before being attended to. So in this case, the first respondent says he waited 8 minutes before being attended to. The second said he waited 11 minutes. The third 5, the fourth 24, like that, up to the last respondent who waited 38 minutes before being attended to. So now, we want to calculate. We want to, I said earlier that that we have three approach to one sample test. It can either be the midpoint, it can either be the average value, and it can either be the change level of performance. So now, if this data set we have here significantly or particularly addressed just one, which is actually the average value based on past research, but now we want to design it, we want to define it so as to fit the midpoint of test variable, midpoint. So this is what we are going to be doing now. We want to design it to fit into that approach. So now, to go about it, we go to transform. So what we basically want to do here is that we want to group it from maybe from 1 to 10 to represent promptly attended to, the second one to mean somewhat promptly, the third one to mean acceptable time, the fourth one to mean somewhat slowly attended to, while the fourth one to mean slowly attended to. Rather the fifth one to mean slowly attended to. So we go to transform. We can either choose recode into the same variable or recode into different variable. But I'd advise to use the recode into different variable, because if you choose this recode into the same variable, automatically it will delete the record, the exact record, the initial record. It will delete it. But coming down to recode into different variable would create another variable, another set of variable for what you're trying to carry out, what you're trying to perform. So you will still have access to the initial data and also this new data. So then we go to recode into different variable. Then thereafter the dialog box appears. So then we transfer this to this place. And then thereafter we come here and name this new variable that we want to create. We name it. I call it new wait time. And also I tell a little about this new variable. I tell a little about it. I would say maybe midpoint waiting time. So then I'll click change. The change has already reflected in this dialog box name numeric variable to output variable. So then we go to old and new values. In this new dialog box, this is where we tell SPSS the old value and the new value we want to assign to it. Of course, you would see some options here. Radio, we call it radio. We have old value and the new value, which is what we're seeing here. So what we need to do here is that we have a value, we have system missing, system or user missing, we have range lowest to highest, like that. But what we are going to be needing here, what we need here is the range. We want to tell SPSS the range with which we want to classify our new value. So we may decide to classify it as 1, 2 to 10. That is 1, 2 to 10. That is what we say here is that from 1 through to 10, we want to represent it with 1. So then we click add here. So this the defined digit comes to this place, saying, which means that we've already defined from 1 to 10, we've defined it as 1. So then we'll come to the second one and say 11 to 20. This is what we want it to mean. We want it to mean 2. So we'll come here and add it again, come to this place, press 21 2 to 30, we want to say it means 3. So which means 3. So the fourth one we said 31 31 to 40 to mean 4. Then we click add. Then 41 to 50 to mean 5. So that's how the whole thing played out. So then we click continue. In that sense, we are done with the definition, with the recording. Then we click OK. So this is basically the output of the results rather of what we defined. Here we calculate. So we defined 1 here. This one means 8. That is from 1 to 10. Any respondent that has a response of between 1 to 10, it will give it one value. That is 1 digit to represent 1 to 10. So this is what we're seeing here. 17, it gives it 2. So like that. So basically I don't really like to have this 2 decimals. I'd come here and change it to 0 here, so we have it reflected here. So then the next thing we have to do now is to give our new variable, which is new wait time. We need to give it a name. Those 1 2 3 4 5 will give it name. That is what 1 actually represents, what 2 actually represents, what 3 actually represents. So we'll define it here by coming to values, click on the new, and tell SPSS that this one means promptly attended to. So then we'll click add. These 2 mean somewhat promptly attended to. So we'll click add. 3 to mean acceptable time. That is, this is the acceptable time. This is the midpoint. This is the mid value. So click 3. 4 to mean somewhat slowly attended to. So then we click it. Then 5 to mean slowly attended to. So then we click add. In that sense, we are done defining, giving those values name. So then we click OK. So in that sense, we've finished defining it. So let's come to this data to see if it has actually reflected. So now we see that the 1 has turned to promptly attended to, the 2 are turned to somewhat promptly attended to. So this is what we're going to be working on. So now in the midpoint, in the first approach, so what we need to do now is to test if the wait time, if the mid value, which is the acceptable value, which is the acceptable 3, we want to know if it's significantly different from this new calculated mean value. So that's what we are doing. So then we'll come to this analyze. From analyze we come to compare means. From compare means we choose one sample t-test. Like I said, one sample t-test means we are testing just one variable. That is the meaning of that one sample. That's the meaning of it. We are testing one variable. So then we'll click this midpoint waiting time. We'll click it, we send it here, meaning that this is the test variable, what we are trying to test. So then we'll click test value. So after clicking test value, we press 3, which is the acceptable time. This is what we are testing. We want to know if this 3 is different from what this variable calculates. We've already predetermined 3 as the acceptable time. So now we want to know if this acceptable time is actually different from what the calculation of this new midpoint value, what it will calculate for us. So then we'll click OK. So after clicking OK, SPSS comes out with its results. So from the results, we can see we have 2 output. We have the one sample output, one sample statistics, and also the one sample test. What one sample statistics is talking about is that is about our variable, the variable in concern, which is actually the midpoint waiting time. That is, it is telling us the description, the calculation of the one sample of midpoint waiting time. So it is telling us the mean and also the standard deviation, the standard error mean, and n, which is actually the sample size, 70. So now we have the mean to be 3.04, meaning that all what we see here actually falls into 3.04, which is actually within accepted midpoint. So that is what that 3.04 is saying. So in that sense, we look at the one sample test. This is where we are testing. This is where we want to test our this one sample statistic mean, which is actually 3.04. We now want to test if there is difference between the 3.04 and the already predetermined midpoint, which is actually 3. So in that sense, one sample test now tests the whole thing. Here we can see we have the T, we have the degree of freedom, we have the p-value, which SPSS actually named significance, two-tailed, and also the mean difference together with the 95% confidence interval of the difference. What we are going to be looking at here is the p-value, which is actually 0.784. That is the criterion with which we are going to use to accept or reject our whether we are going to accept or reject if or whether there is difference between the two means. So here we have 0.784. Normally we do agree that we may decide to use a 95% confidence level of significance, and also 1% level of significance. What we are saying is that we want to decide on whether to accept or reject the difference between the two means, between 3.04 and 3. We are using that criterion to determine it. So at 5%, at 95% level of significance, what this one is saying is that there is no difference between the two. That is, the p-value is 0.784. We've actually agreed that 95%, which is 0.05 level of significance. So this p-value is over and above is 0.05. Normally we do agree that if a value is less than 0.05, there is statistical significant difference between the two. But if it is over 0.05, there is no difference between the two. So that is what we're saying. And even if it is, we still agree, or we still want to use 95% level of 99% level of significance, which is actually 0.01, which is actually 0.01. And we convert it to have 0.01 anyway. So this p-value as well still holds that there is no difference between the two. So now, in that sense, we have our t, which we could use or we can use to calculate some other stuff. We have our degree of freedom, which is n minus 1, and also the p-value, the mean difference, which is the difference between the calculated mean and the predetermined midpoint. We can see we have 3.04 and 3. 3.04 minus 3, we have 0.04, which SPSS gave us as 0.043. So now we now have the 95% confidence interval of the difference. What this one is saying is that we are 95% sure that the mean difference of 0.043 falls between minus 0.27 and 0.35. That is, this difference falls between the two intervals. So we are still in the line. We are still in the we are still right. So that is basically what one sample test is all about. Now we've tested the midpoint, the mid value, if there is a significant difference between the two, and already we find out that there is no difference between the two based on the first approach, which is actually midpoint of the test variable. So now we want to move to average value based on past research. So now also we would have to determine the average value, the mean. The mean. We would have to predetermine it. So then we give SPSS. SPSS will still run the calculation to see if there is a significant difference between the two. So now to go about that, we would need to go back. We would need to do the calculation either from here, or we come to this place and run the whole thing. So now we come to analyze as well. So then from there we move to one sample t-test, compare means and one sample t-test, which we do. So then we have the dialog box out. So then what we need to do now is to transfer these midpoints waiting time. We transfer it back to its original position. So then we move the waiting time of the patient in the hospital. We move it to the test variable, which is actually the variable we are testing. We are testing it. So then we come here to the test value. Then we predetermine it. Let's say we chose this to be let's say 32. So then we click OK. What we actually did here is that I tried to make sure that I make use of the one that is not significant and the one that is significant. So the first one is not significant, but the second one, we want to look at it if it is actually significant. So I decided to make use of 32 as a test value. So SPSS calculated what's it called, one sample statistics and also the one sample test, which is actually as the same thing, which is actually similar. I wouldn't say similar in that sense, but the same procedure with what we first did. So now we have our mean, the calculated mean on the variable, the test variable, to be 26.04, and also our predetermined mean to be 32. Now we want to determine, we want to know if there is significant difference between these two means. So now we have the t, we have the what's it called, degree of freedom, we have the p-value, we have the mean difference, we have the lower confidence interval and the upper confidence interval. So what we're trying to do now is that we want to know if there is significant difference between the two. So now, as I said earlier, we come here to this p-value, this SIG, and we look at the figure, the value, which is actually 0.000. What this one is saying is that it is significant if we base our criterion level on 95% and 1%. So this value is lower than 0.05 and also lower than 0.01. In this, we would decide that there is significant difference between the two. So in this sense, where does the difference lie? Does it lie to mean that this new mean is greater than the previous mean, or the previous mean is greater than this new mean? So now we will conclude that the previous mean is greater than this new mean. That is, in the previous study, patients wait more than this new study. That is, there is an improvement. There has been an improvement in the waiting time with which respondents had to wait before being attended to in a hospital. So that is what this new uh, uh, one sample test statistics is saying. That is, there is difference between the two. Where does the difference lies? Where does the difference lie? It lies that previous me had to wait more than this new me, which means that there has been an improvement in hospital attendance. So that is what one sample test is actually saying. And to of course, there are some assumptions that guides one sample test. We don't just run the test just like that. We have some assumption that guides the one sample test. Of course, we would need to look at those assumptions and see if this one sample test actually violates this result violates the assumption. So if this result violates the assumption, there is no basis for us to accept this output. What that one means is that there has been what's it called? I would say there has been issue. There is an issue in 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 the data collection. Yeah. So then let's move to analyze to see what we're talking about. Of course, we'll come here, then we click descriptive statistics. So then we come to explore. This explore means we are trying to know more about our data. We want to know what's happening to it. We want to confirm some assumptions. We may decide to look at histogram to justify the assumption, stuff like that. So then we move this to the dependent list. It's actually the dependent one, but it's alright. We move it to the dependent list. We click statistics. Actually, here we really do not have much to click here. So then you can see the confidence interval for me is actually 95%. We may come here and change it to 99, whichever way we want, but it's alright. Let's just leave it like that. So then let's come to options. So here we have the exclude what's it called, cases list-wise, exclude cases pair-wise, like that. We really do not need to venture into this as well. So plots, let's look at what plots has for us. So now we may decide to look at some stuff, check some videos here, but basically I would advise us to remove this stem and leave, because of course it will give us the same thing as histogram, but let's just use histogram to display our data distribution like that. So then we come to normality plot with text. What this one is saying is that we want to plot a normality plot with text. We want the normality plots and also we want the text. So this is what this one is saying. So then we'll click normality plot with text and continue. So then we'll click OK. So SPSS will load the results. It is coming still running through the results. Also, so then let's come down. Let's wait for SPSS. Sorry, my system is kind of low. It will take some time to come up. I'm sure it is already loading. Yeah, result is out now. So then look how what we have here now. We have descriptives and also we have normal test of normality. So then what we need to look here is that we need to look at the mean. We have the mean has 26.04, and if you look at what we have here, you can see that it is still the same thing, 26.04. Also the standard deviation is 13.57. Let's look at what we have here. It's still the same thing. So then the minimum value in the data is actually 2, while the maximum value is 50. So range, we have range to be 48, interquartile range to be 23. Basically, what we're going to be considering in this descriptive statistics is actually the skewness and kurtosis, which we can use to know whether the data is normally distributed or not. But I wouldn't advise us to use this because we have another box, which is test of normality, that basically addressed the main issue. So what we're trying to, the normal test of normality, the normal distribution. Of course, we need to look hard at the Shapiro week to determine whether it is normally distributed or not. And here we have the Shapiro week statistics to be 0.962, the degree of freedom to be 70, and also the SIG to be 0.034. What this Shapiro week represents what's it called, the parametric method, the parametric way of testing normality. If this one is violated, we may have a cause to look at some other look at this Kolmogor's manner to actually proceed on our test, on our exercise. So now we need to look at this Shapiro week. In this Shapiro week, we have the SIG to be 0.034. What this 0.034 is saying is that, let me say, test of normality. The assumption is that it's not normally distributed. That is, the data is not normally distributed across across the population, or it is normally distributed. So the null hypothesis is that it is normally distributed, while the alternate hypothesis is that it is not normally distributed. Now, to really decide on whether it is normally distributed or not, this assumption must be violated. Violation, what I mean in this case is not that, what I mean by violated is that we have to reject the alternate hypothesis and accept the null hypothesis. The alternate hypothesis is saying that it is not normally distributed, while the null hypothesis is saying that it is normally distributed. And in this case, we've decided that our level of significance should be 95%, which is 0.05, and a value less than 0.05 means that we are rejecting the null hypothesis, while the value greater than 0.05 means that we are accepting the null hypothesis. But in this case, we are going to reject the null hypothesis that it is not normally distributed. We are going to accept the alternate hypothesis, that is, it is not normally distributed, while we reject the null hypothesis, which states that it is normally distributed. But basically, we really do not need to worry about this assumption here, because the degree of freedom, the sample size is over 30, which is the moderate sample size to accepting or rejecting this test of normality. If the sample size is less than 30, so then we need to really consider this test of normality. But if it is over 30, so then we really do not need to bother about it, because because that is what the assumption says anyway. So then let's look at the histogram to really justify what we have. We look at the histogram, we look at the QQ plot, normal QQ plot, we look at the distribution, which is still fairly okay. I really like to use this normal QQ plot of waiting time, and also this test of normality. Of course, you can use this skewness and kurtosis to know whether it is significant, is normally distributed or not, but I really do not like to use it. We look at, I think that's basically what one sample t-test is all about, and I hope you find this video useful, and Now to calculate the effect size, I want sample of the test. That is, I want to know the degree at which the mean deviates. So that is basically what we want to do using calculating the effect size. And to do that, we will use the mean difference divided by the standard deviation of the mean, the calculated mean. So that is how we are going to make use of the effect size. And also, like I said, we want to know the degree at which the mean of the test variable differ from the test value. That is, how far is the mean, the calculated mean, away, or how far is it from the test value in our standard deviation unit. So that's why we use the standard deviation, of course. So then normally effect size of 0 means that the calculated mean is the same thing as the test value, while deviation away from 0 means that the effect size becomes larger. And normally effect size range from 0 to infinity, negative infinity to positive infinity. And effect size of 0.02 simply means that it has a a small effect size, while the effect size of 0.5 means that we have an average effect size or medium effect size, while effect size of 0.8 means we have a larger effect size. So that is basically what effect size is all about. So now sorry, I made a mistake here. I have to put standard deviation. So then open bracket STD. So mean difference divided by standard deviation. In our case, we have the mean to be mean difference to be 0.596, and we have the standard deviation to be 13.57. So if we divide it, we will have 0.439, which approximately is the same thing as 0.44. And if you want to put it in percentage, you will say that if the effect size, the effect is actually 44%. That is, test variable differ from the test value by 44%, which is actually a moderate effect size or medium effect size. So that is what effect size is saying. So now let's see how to make use of to write the results in APA format. So to do that, we come here, we have writing your results in APA format. So now this is what the result is all about. A one sample t-test was conducted to determine whether the mean waiting time was significantly different from 32. That is, the mean test variable, the mean of the test variable is different from the previously conducted. It's actually 32. I want to check if it is significantly different. So then the accepted mean waiting time in general, which is 32. They've already accepted it. So the sample of 26.4 with standard deviation 13.57, that is, the test we are carrying out is the mean of the test we are carrying out, the mean of the variable we are carrying out is now 26.04. We are now saying was significantly different from 32, the previous mean. With what? With the statistics in front. That is, the t is actually minus 0.367 with the rejection criterion or criterion level to be 95%. The 95% in confidence interval for the mean waiting time ranged from 0.19 to minus 2.7 That is, the main difference is between point 919 points minus 9 points minus 0.19 and minus 2.72. So the effect size of D is 0.44, which is actually 44%, indicates a medium effect. This points out that there has been an improvement in the waiting time of patients in the hospital before being attended to. That is, patients now spend lesser time waiting than in previous study. Yeah, so that is basically what this one is saying, and I hope we all find this this video should very much important, necessary, and useful. And thank you for joining us.